Okay, when you're trying to find what the weight of this person is this when you have to set it them equal to each other, like the
Yeah, the weight times the distance equals the weight times the distance.
okay.
And it is 820. We have 1, 2, 3, 4, 5, 6, 7. Here. All right, we're just working on the review for the next hour or so. And if you have questions,
This is calculus.
calculus. Okay. And I'll have a copy of the key to that. But if you can't read it or don't understand what I did, let me know.
I got it at like 6:30 in law school already.
Was it good?
Honestly, I didn't like it. And no, I'm not joking. Honestly. I got 6 for nothing.
How long was it?
It was like 30-ish minutes.
Yeah.
But for when I have to take the derivative of e to the x, like the derivative of e would be e to the x and then times e to the x,
Right.
right?
Right.
And then how would you
And that's it. Well, you could
would you like put the e to the x in front or
e to the x times e to the x, right? Yeah, or you can add the exponents, like if you have x to the a times x to the b, that's equal to x to the a plus b. So you could add e to the x plus e to the x, right?
e to the x?
Plus 1, no, plus x, like that.
Mm-hmm.
I mean, you could do that, and it's just one term, but I would take it either way.
Oh, okay.
Yeah. Yes. Yeah, and here's this, and you did a lot better. However,
Yeah, I saw.
almost.
That's so
But
close.
I went ahead and just left this as the actual grade, but you
Okay.
did bring your average up. quite a
Okay,
bit, so
yes,
that's good.
thank you.
Anyway, so what's your question?
25. So I see on here, but I'm not sure. So I know you use this one right here.
Right.
But I guess I thought you would take the out of this.
No, because you have that something to the x, right? And so the thing is gonna be that thing to the x, the derivative will be cosine x to the x times the natural log of cosine x. And then times the derivative of cosine x.
Then was, oh wait, that's okay.
Yeah.
Times the derivative. So that
You want to put parentheses around the cosine x to show that it's the natural log of that.
Okay, I see.
Wait,
Okay.
can you explain that to me too? It was for 25?
Yeah.
It was, so like it'd be sine A.
So you're doing this kind of
Yeah,
thing
the-
right here.
right.
Yeah.
And so you would,
Do cosine of, I mean, if
So you
yeah,
sine
cosine to
it.
the x times the natural log of cosine. So something to the x is something to the x, natural log something, and then times the derivative of cosine x.
which is just cosine?
No, derivative of
Oh,
cosine.
right, yeah. That's, it's,
Negative sine, right?
I'm confused on this one.
Okay. And there's a lot of blah, 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 but, please start here, you got this equation. And the acceleration is derivative, the acceleration is derivative of the velocity. And so you gotta take this derivative to get the acceleration and, and then take this metric difference. Okay, so you don't have to take the actual derivative at this point, you will do that on number. This one, I can't take the numbers now. But, so you put this in your calculator. So y equals u to the x. Yeah, okay. And then go to your table set. I started at 3, but use a 0.1. Okay, and go to your table and go up 1. Okay, so then you'll use the, you're gonna get the slope using the point on this side and that side of the 3.
Okay,
That's symmetric.
and that's all we do on that one?
That's all you do on that one.
Okay.
Okay. I'm ready. And then you got to make the door higher, so that you're averaging it up a little bit. I think this is a good effort. Average pretty good, yeah. You're doing what you need for. Any papers?
So on this one, it is 30. Whenever I put in the values that was asking for, it said 1.9993, 999 for your fixation fee. It didn't give me that. Even though I put in the 0. Like skips.
Okay, did you say 1 point? Yeah. Oh, and then 97, because you're probably getting, delete one of those 9s.
But I thought the correction was that this should be 1.
No, it should be removed.
Okay.
Maybe I made it look like that. Because you're going out 3 decimal places. Yeah.
That helps.
Well, you have a bunch of weird errors. Oh, okay, so you have two different things.
Yeah, that's the derivative.
Wow, so you have errors on your side. Here's the Y2. But that's fine, I guess. And so you put parentheses, minus. I don't want this parentheses here yet.
This is, I'm putting this in together with those notes that we
Oh, okay. And then
Same
the-
with that one, so we just need to match those all off. And then for this, am I going to use it the room or the It's not
Good question, but we got that in, and then do the data for that. trying to prove that the derivative of cotangent is this. So another way to write cotangent x is this. You think of it as cotangent of that. And so start with that, like y equals that, and then, well, this will be u and that'll be v, but you're still gonna find y prime. Is u prime v minus u prime v squared. Let's see what else. So we will have two classes on Monday. A 35-minute class first period, and then another review in the afternoon. Oh wait, I'm doing that. Okay, we do have to, yeah, so a 50-minute and a 60-minute class time on the 14th, and then exam on Tuesday. Question?
Yes.
And I will be taking the review up for a grade,
What is the most time efficient method?
to prove that something's continuous. Remember the old saying, differentiability implies continuity? And so if you can prove it's differentiable, that'll prove it's continuous. So can you take the derivative?
And then speed?
And since you have the derivative, you must be continuous.
Do we have chapel on Monday?
No.
Oh, thank you.
And so it's regular dress on Monday and then Spirit Day Thursday. Christmas Spirit Day.
Wait, we don't have chapel next week? Okay.
Does everybody still have the track roll in their calculator? That's where you do things we learn. This thing right here. And they do, which one are they asking for? Sine, yeah. So they do the inverse tangent and then they do inverse secant, but it's the same step. Where you draw the little triangle and then try it yourself.
Well, I guess I'm confusing the triangles. So,
First, you're gonna take the sine of both sides. Did you write down the little, I think I had the steps, was that steps to
Oh.
different? No, that was steps to different thing.
once-
That's the ones that are limits, yeah. So on these, I can write those steps down too. And then whatever the trig function is of both sides.
What is the trig?
Like in your case, for that problem, it's sine, it says inverse sine, y equals inverse sine of x. So the trig function in this case is just sine. And so you'd say sine of y equals x, because the sine will cancel the inverse sine. And the second step is to make your triangle in quadrant 1 and label sides with using SOHCAHTOA.
This is Belcher.
Yeah?
Right here, what calculator?
Yes. Did you get it? Oh, yeah. I was wondering if you had panicked and then remembered where it was.
Thank you.
You're welcome. And so like in this case, if that's over 1, this is y. That's a label. Label, there we go. Label size using SOHCAHTOA. And so sine is opposite over hypotenuse. And so x would be opposite and hypotenuse would be 1. And then Pythagorean, so you get the other side. So that ends up being the hypotenuse squared minus the side squared, and then the square root of that.
Wait, back it up a little bit. Wait.
So like if that was a, then a squared plus x squared equals 1 squared. And so a equals, you subtract the x from both sides, the x squared, and then you take the square root to get rid of the, and then 1 squared is just 1.
Oh, I see.
So whether it's sine, cosine, tangent, secant, cosecant, that'll make the sides different.
Wait, so do you keep the squared on the x, right? Not the one?
Right, because x squared is not the same as x. Like 1 squared is the same as 1.
Okay.
And then go back to your equation and take derivative of both sides with respect to x. With respect to WRT(x). And what that means is you'll have that y prime in there. Like the derivative of sine of y is cosine of y times the derivative of y prime. And then derivative of x is 1.
Wait, so you take the derivative
Of the original equation, I mean, that, the one that you got after you started with this, you went to
Okay.
this. So this goes to that, and then I guess I should do this. Okay, and then solve for y prime. So you'll divide both sides by cosine y to get y prime by itself, in this case. And that, you're solving for y in terms of y. Because you have a y right here. So now you got to use your triangle to get equation in terms of x. So you say, well, cosine is adjacent over hypotenuse, right? So 1 over adjacent is the square root of 1 minus x squared over the hypotenuse, which is 1. And then you can just simplify and that should be what you have in your formula sheet. So it's these same steps every time, whether it's sine, tangent, cosine, or whatever. You just have, the triangle will look a little different, and so your formula will come out a little different.
Okay. Thank you.
And then you got the steps.
I'm gonna write this
Yeah.
down.
You can't do the examples, but you can do the steps.
Thank you. should be the answers.
Mhm.
And this is between the two numbers. And it would go to B. And that number.
Yeah.
And on my chart, if you do one for are you implemented that to do
Yeah,
that?
no, I don't think I did it right. But your limit is 4, right?
Yeah, because I have.
But
it
okay, the
originally-
limit, okay, so these are, what it is? Yeah, I got ones, okay. The X begins at 90, yeah. Okay, so you did, 0.01 away from 4. So that means that would be for the Y would be 4.01 and 3.99, like 990.
I have the first one.
Yeah, they could go either route. Okay, that was 991. Okay, so let's do it. That's a right. Capital is a straight dot to dot. Straight line. 500. Okay, so yeah. Where you do half the first one, half the last one, plus the one in the middle, and then you multiply by 2 and X. This is the equation. Add the values of Y, half the first, half the last, and you multiply by 2. Right. So the Y value, you do need to make the chart, figure out what the Y value. Yes. So you'll have 4 values, even though there's, because you have the beginning and the end.
Okay.
What do you have?
Have you put into the
Okay, okay, so it's, we got -3 cosecant squared of 15, basically. Okay, so that's also cosecant of 15 squared, right? And then cosecant, because your calculator didn't have cosecant button,
over.
so you have to do 1 over sine of 15, and then have that squared.
Thank you.
calculator isn't provided.
Oh, okay, because it's only the sign that, I mean, it's in the denominator. In other words, this -3 should be on the top because,
Oh, it's been on top.
yeah, because this, you're just taking the reciprocal of sign, not
So it'd be
not the
very,
third. The sine of 15 squared, into where the sine is squared, not the 15, the whole thing.
So we would look at that.
No, put the square on the outside of the parentheses. You want to square the sine of 15, not just the 15. And then you got two, wait, yeah, like that, and then, there you go, wait, no. Parentheses square, yeah, two parentheses in the square. Yeah. I did it right here, which is pretty much what you did, because you multiplied the -3 and did that on top.
There you get -7.
Are you in radian?
Well, that was my fault.
Okay. Well, you want to see if there's a difference with approaches. Yeah, so You're gonna put in this thing.
Let me get my calculator for this one. Just one thing.
So that one is- you probably, because I bet they're only dividing the second one, you probably do insert parentheses and
Yeah, here. Well, 'cause I have another.
you might even need more than that, so I'm thinking the one right all in here. So, yeah, cosine minus 1 over cosine 2, so you'll need parentheses here, parentheses here, and a parentheses for the whole thing. That's gonna be parentheses, parentheses 1, parentheses divided by cosine. So parentheses, okay, yeah. Parentheses. 1 divided by cosine 2, parentheses, parentheses, divided by,
Okay.
and then parentheses x minus 2.
So negative.
Negative 0, yeah. And so then the,
Those are the two that were the answers.
oh, and they have cosine x. And so in other words, they've got this here, so you need another parentheses here. And then another one here for the 2, yeah. Yeah.
Okay, thank you.
Easy, right?
This is special.
How did you tell you to type that in? I did not do that.
It's called parentheses. So if I were to do two parentheses and have
Divided by cosine.
and you said that at the end,
and
and then two parentheses, you don't need to take this three and side over like you did.
Okay.
But in your answer, you have to do that. Before. Three. What are we supposed to do?
3
Yeah.
divided by.
Oh, wait, no,
So
that's
you just plug in one here.
Okay.
You have to take
and then divided by.
Yeah.
But if you do it, you're like, you do it before, so I don't think that's right.
Now, how does she expect us to know?
I
how to
know.
do that?
I'm like, just like usually just put one. I'm like, oh,
They should just have a secant button.
I know, right?
Okay, so it's 3 times that, yeah. So I think when it comes to the 0 that you're gonna have, if you have x plus 1/3, you're gonna have a 0, like when you solve that for 0, you get, I think you do have to put it up in front. Okay, x plus 1/3, like if you have, you set that equal to 0, then x will equal negative 1/3. Right, okay, and then if you have 3x plus 1, you set that equal to 0, you subtract the 1 divided by 3, so you will still get x equals negative 1/3. But these are not the same equation. Like think about it, if it was a line, this one would have a slope of 1 and go through 1/3. Would look like that, whereas this one would go through 1 and have a slope of 3, right? And so when you're finding the zeros,
Why do you need to find zero though? Don't you just plug in one?
well, when you're doing this thing right here, doing the factoring to find where the x intercepts are, right? And so if you use x plus 1/3 or you use 3x plus 1, you'll get the same x intercept. But that doesn't mean it's the same parabola.
Okay.
Okay, and so that's the problem in this thing is because when you simplify, you're not just simplifying it to get zeros, you're actually simplifying it to get this final line, that actual y equals x plus 3x plus 1. And y plus 3x plus 1 is not the same line as x plus 1/3. So you can, if you're just trying to find where the x-intercepts are, leaving it as 1/3 is fine. But if you're trying to actually simplify the equation, you do have to slide it over.
Okay.
So usually, most people go ahead and, who else is not sliding it? Yeah, Lewis.
Wait, what?
Which one of them, a number?
Five.
Number
I
5.
just synthetically divided it.
Oh, so you just synthetically divided, so you ended up with 3x plus 1. Okay, she did the slide and divide thing.
I tried doing that, but it was too complicated, so I just used
Oh.
synthetic division.
Okay. Yeah, and so we were talking about how you could leave it x plus 1/3 or
Mhm.
3x plus 1, but for actually finding that simplified line, you can't leave it x plus 1/3.
Oh,
They both have the same, you'll still get the same x-intercepts for if that's what you're being asked for, it's okay. But when you're being asked for this, you really have to.
Oh, okay.
What did you get on 4? Did you simplify it down to 3x plus 1?
On what?
I mean, 5.
Oh, wait.
Yeah, you divided 2 to 3 plus 1, so yeah, that worked out good. We also, let's see that one thing.
So I'm trying to find the number for error, so I don't think I'm doing something.
30. This is
Oh,
other
wait, do
two.
you not have to do like this slope?
No, no.
Oh, okay, so whatever this is goes here.
Yeah, so it looks like that's the middle term.
Yes.
Yeah.
Thank you.
7, I think I just did it wrong. I don't know exactly,
And so,
yeah,
okay, so you're,
because I did the.
you just plug this in and go to your table, right?
Mhm.
And so you started at 3 and had 0.1 for your table set. Okay, and then you're supposed to use this minus this or this minus that.
And that's what I did, but I got, what was this?
And what's my key?
It was my, oh, sorry, my question was on 6 plus 7.
Oh, okay.
6 was 1, or 7 was 1.
7 times 8, 6.
Sorry.
Okay, so what is the electric value of delta? So you're trying to find delta. And so you have an equation, the simplified equation of 3x plus 1, y equals 3x plus 1 triangle. And then you also know that epsilon,
Did you get the white?
that's when you simplify it up in the 5.
But it didn't reference 5 here. Number 1.
Right, the number, you, all of this is the number 1. And so part of this is knowing that the problem 1 you have to simplify. And you know that the limit is 4. And what was the point? You were at 1 right here, right? 1 and 4. So 1 4. Epsilon being 0.007.
Yes.
And then that's basically like this point here.
So I have to plug in y equals 3x plus 1 in my calculator and then the graph.
No, you're gonna, this is with the algebra.
And how much you figure out before? Okay, never mind.
Okay, so instead of y equals 3x plus 1, you're gonna say y plus epsilon equals 3x plus delta plus 1. You're replacing y with y plus epsilon and x with x plus delta. Okay, where this is X, that's Y, this is epsilon. So the only thing you're looking for is delta. Right, so this is in here. And so you're gonna have 4 plus 0.007 equals 3, and 1 plus delta plus 1. And then something else. Okay, start with the original simplified equation, replacing X and Y.
Can you help me with 31?
Okay, so you're trying to find if it's to prove something's continuous. And remember, we had that saying, differentiability implies continuity. And so if you want to prove that something's continuous, that it has continuity, all you have to do is prove that it's differentiable, because differentiability implies continuity, right? So is y equal mx plus b differentiable? Can you take the derivative of that?
Yes, it would just be.
Right. And so if it has a derivative, then it must be continuous, because
Oh,
differentiability
okay, I'll
implies
be writing
continuity.
it down. If it has a derivative, it's continuous.
Because D implies D.
Okay, thank you.
D arrow C, is what we were doing.
I still think it's working on 7. Or 6.
Hmm.
Is it out right now? It's not good.
It's just my presence that reveals the errors.
On 34, we need to simplify this.
Yes,
How-
factor. So
So,
like you got some 2x plus 5, 2x minus 5 over here, and some 2x minus 5 over here, and some 5x plus minus 1 here, and some 5x minus 1 there.
so
And then you have you also have 12 and 10, so you could factor 2 out also.
so like, which one would you do first? Like, would you pull the 2 out?
Yeah, put the 2 and then parentheses, what's the fewest? Okay, like you're gonna have some 2x minus 5, so put 2x minus 5, and how many of them is
There
it?
would be 5, because there's 6.
Right. Yeah, so you got it. And then how many of the other one?
Just one.
Just one. Okay, and then big
And then bracket.
bracket, yeah. So what do you got left in the first
That
one?
would be a 6.
Uh-huh.
And then
And then over there you'll have
plus.
a 2x minus and a 5, right?
Yeah.
So you put a 5 in front. And then you'll distribute, combine like terms, and get that last bracket down to a single binomial.
So basically, you don't do anything else with these. You
No.
you leave those the same.
Yeah.
Okay.
Should this be a or a decimal?
If I'm
Um,
only for dividing, you do the negative, but then for that, or like multiplying.
Okay, so you're doing, this is a product, so you're just using product rule. Where's that? Right, which is what with using B?
This.
Yeah, that's the product rule. Okay, so then you have two things.
But wouldn't it be plus? This would be plus, or would it be negative?
It would be plus. I see an error. Yeah, because it's quotient rule that uses a minus. And so where is that gonna, that's gonna affect everything down to here. It's gonna be a plus 10 and a minus 25.
So then it would be 40.
Yeah. So my key is wrong on 34.
Yeah, I was wondering that too.
Yeah, 'cause I had a minus instead of a plus in the power and the quotient. Yeah, I have it right here. Yeah.
It's okay, I'll just change that. And then,
Okay, so the key on 34
It would
is
probably-
wrong.
yes.
Let me make sure. Did y'all hear that? Ladies, Maddie, Catherine, the key on 30 is wrong. And hopefully Brian,
40x minus 31?
is that what you got? 40x minus 31?
Yes,
The key on, we said 30,
it's 34.
34. So I'm saying that next to the speaker, so Brian will hear me say that. The key on 34 is wrong.
What does the answer?
Everything right in that last parentheses, because I had a minus here instead of a plus. So you should add 30x plus 10x to 40x. And then negative 6 minus 25. negative.
Okay.
May I grab something from my locker? May I grab something from my locker?
Miss Sophie, did I leave my sheet up there?
The actual, yeah.
Thank you.
last round, the 29 of physics, I've like written everything out, but like I'm not sure how to incorporate the mu into the
Okay, so schedule stop, so we're using, and it gives you mu, right, yeah. Determine the stopping distance. So you gotta use the net force. Okay, you have to find the net force, then you get your acceleration from F equals ma, and then once you have your acceleration, you get the rest. Okay, and so, the force of friction is mu Fn. And I think the friction is the F net, because the friction is what's slowing it down. It's the only force. There's no other force pushing it or pulling it or anything.
Oh.
And then once you get that, that's equal to ma, and so that way you can figure out what a is.
wait, then what's the normal force?
What is the normal force?
Um,
What does normal force mean?
what does it mean?
Yeah, like if this is the car, how would you draw that?
It's like the arrow goes up.
Right, which is equal to what?
Uh,
And why isn't it moving? Right, the gravity, which is what?
9.8.
Well, that's G is 9.8.
Oh, it'd be that times
The WG
yeah,
is
the weight
mg, like that, right?
or the mass.
Right. And you're given the mass.
Yeah.
Yeah, so you can
Oh,
find,
okay.
yeah. One minute. Hold on, just keep going.